The next topic in the solid design principle category that we need to talk about is the I within solid, which stands for the interface segregation principle. Now, this one, once again, may seem a little bit obvious to you when you first start to look at it, but you would be shocked to know that this is an issue that rears its ugly head quite often and can cause quite a bit of confusion in code, especially if you are inheriting some code from someone else that you haven't had a lot of knowledge or a lot of previous experience working with. This is definitely something that's going to throw you for a loop. So let's start to take a look at this invoice printer class just a little bit. Now let's say that we want to start designing our code to be a little bit more testable, or in the case of some classes, for instance, the interface printer, maybe we want to make it more mockable within our unit tests. And if you are familiar with using mocks in most frameworks, that most of the time you're going to want to be mocking or injecting mocks that implement an interface. So let's say along the line somewhere we decided that we need to create an interface that's going to represent our different printers, or maybe in this case an invoice printer. So let's go ahead and start to create an interface. Now this is a relatively common practice. So I'm going to say that I'm going to have an I invoice printer interface. And this is once again going to be public. And this interface is going to define a couple different methods. So this is going to have a void that's going to be called print, and it's going to take in an invoice called invoice, and that's fine because we've already got something like that here. So now let's also say that in the future we are expecting, or we're going to be implementing, say, maybe a void or a print complex, because remember we created a complex invoice. So in this case, maybe we're going to have to create one of those. So this is going to be a complex interface, and let's just say somewhere along the lines we had some other print method, and we'll say some other print method. This is some great idea that we had, that this is going to be some great way to print an invoice that we're going to work on in the future. So it's always one of those concepts where we're planning for something in the future that we don't necessarily know or are unsure if we're actually going to need that or not, which is fine in most cases, but you can definitely run into some issues by doing that if you start to think too far ahead, because oftentimes we start to then plan and design for things that really aren't going to happen. But all other things aside, let's just say we've defined an interface that looks like this. So we'll clear up some of our using statements here. So now we want to make sure that this interface is applied to all the appropriate classes, and this is going to be one of them. So we're going to say, all right, this is going to implement the invoice printer interface. We'll go ahead and implement these other methods here. So now we're going to come down in here and we're going to say, all right, yes, I have something that I want to do for this guy. So we'll put in some logic for this as well. So some logic is going to go here. And that's pretty much it. I don't have any use for this just yet, so I'm not going to worry about it right now. So this is one of those telltale signs of going against these solid design principles. So what's happening here is this particular class, the invoice printer class, is being forced to care about something that it doesn't care about. So this I invoice printer interface defines this some other print method. So it's going to do something fantastic. We just don't know what it is yet, so we threw it in the interface anyway. Well, the problem is now we are forced, because we are implementing this interface, to include this some other print method within our class that it either doesn't know about or really doesn't care about. And then we oftentimes put in something here like a throw, or maybe we start to decorate this with like an obsolete or something like that, which really starts to muddy the waters and really make it difficult for you, as well as other people that are going to have to work with this code, to truly understand what's going on here. So the interface segregation principle says that we should never force any particular class to implement some member or some characteristic of an interface that it doesn't know or doesn't need to know or doesn't care about. So how do we get around that? Well, it doesn't mean that we can't have this some other print method existing somewhere in an interface, but maybe as far as this is concerned, we shouldn't put it in the iInvoice printer interface. So how can we work around this? Well, the way that we can do that is to start to break apart this invoice printer interface. So we know we're going to need these two. That's going to make sense, but we're not quite ready for this one yet. So what we can do is we can create another interface, which is going to be the iSomeOtherPrint interface. And in here, we're going to then extract out this particular method declaration. We'll put that in here. And then we'll make this public as well. And now we can save that. And now within our invoice printer class, we can remove this kind of empty implementation of that method that we don't need or don't care about. So now we don't have to muddy the waters in the invoice printer class with something that we don't need nor care about. And this iInvoice printer interface is much cleaner now. So we know that we're only applying this interface to classes that need everything within that interface. And then at some point in the future, should we decide that we truly need that some other print, then we can just simply tack that on here and add that interface on here, and then we can implement this class and then go forward with writing the code to make this whole thing make sense. So once again, the whole concept behind the interface segregation principle is just don't force a class to implement some characteristic or some feature of an interface that it doesn't need nor care about. So in order to follow that rule, you simply extract what's not needed into separate interfaces, and then you can ultimately chain them together whenever you need them. But you can also go on to the other extreme of that, where I've seen in several instances where you can have an interface that might have been 15 to 20 methods and properties long, and then you extract all of those bits and pieces out into their own separate interfaces. I can definitely see that being a little bit overkill, because once you start creating classes in this way and you have to chain 15 to 20 interfaces off the end of it, that can become a little counterproductive as well, because it takes a long time for you to then dig into each one of those interfaces and figure out what belongs where, and maybe do I still need this or not, and that becomes a little bit of a mess too. So once again, I would think of this as similar to the single responsibility principle. Is I would group things together, and by things when talking about operations or methods or properties that kind of belong to the same logic structure. So that whole concept of within the invoice, we talked about the calculation logic. So maybe you could create an interface that embodied that calculation logic. And then if you had other database or some sort of IO logic, you can group that into another interface. And then you can start to put these building blocks of interfaces together. But once you become too granular, it becomes very difficult to read and maintain ultimately, because then you have a whole lot of things that are going on at the class declaration level that can become quite confusing as well. So there you have it. That is the interface segregation principle. And then finally, we're going to reach the final principle that's being defined within Solid, and that is D, which stands for the dependency inversion principle. And that's what we're going to cover next.